Today I'm going to be doing a video on the reactions of alcohols, and this video is specific to the OCRA exam board. But firstly, I'm just going to do a quick recap of the properties of alcohols, just so it's a little bit more easy to understand the reactions. So firstly, we all know that alcohols have the functional group of OH or hydroxyl, and due to this, the alcohols have a suffix of OL. For example, hexanol, methanol, and ethanol. So alcohols are most commonly used in drinking alcohol, fuels, solvents, and feedstock. Alcohols have hydrogen bonds, which makes them soluble in water. Now they are soluble in water because the hydrogen bonds in the alcohol form more hydrogen bonds with the water molecules in water, making it soluble. And lastly, alcohols are polar due to the OH functional group, having an oxygen which is more electronegative than the hydrogen, resulting in a polar molecule. Now, we can move on to the reactions, and we are going to be covering 4 reactions: combustion, incomplete combustion, oxidation, partial and complete antihydration. So firstly, we're going to have a look at complete combustion. Now, this is a process where the alcohol reacts with a sufficient amount of oxygen and it produces carbon dioxide and water. In this process, the oxygen completely reacts with the alcohol, and releases the maximum moles of H2O and CO2 possible in the reaction. So, as we know, combustion is exothermic, but with the alcohol, it releases a great amount of energy in the form of heat, which makes sense that alcohols are used as fuels, because when alcohols are combusted, they release a lot of heat. Moving on, we have incomplete combustion. Now, incomplete combustion is a combustion reaction of an alcohol or any compound when it's combusted but with insufficient amount of oxygen, so there's not enough oxygen for the reaction to occur properly. So as a result of this, there are 2 products formed: carbon monoxide and H2O. As you can notice, carbon monoxide is formed, whereas in complete combustion, carbon dioxide is formed. Now, carbon monoxide has 1 oxygen atom, whereas carbon dioxide has 2 oxygen atoms. So we can see how in this reaction there was insufficient amount of oxygen, therefore carbon monoxide has been produced. So as this is a incomplete combustion, not as much energy is released to the surroundings in the form of heat, as the reaction hasn't occurred properly and alcohol hasn't reacted enough. Next, we have the oxidation reaction using the reflux setup. Now, in this reaction, so we just have a little side note here. In this reaction, alcohols, which are primary and secondary, can undergo oxidation by being heated with potassium dichromate and an acid catalyst, which is sulfuric acid. To shorten this up, you can just say acidified potassium dichromate. Now, by primary and secondary alcohols, I mean the position of the hydroxyl group attached to the alcohol. So in primary alcohols, the hydroxyl group is attached to the end or the beginning of the chain, where the OH group is attached to 1 carbon atom and 2 hydrogen atoms, whereas in the secondary alcohol, the OH functional group is attached to 2 carbon atoms and 1 hydrogen atom. So this determines the way they react and what they produce. But in this case, we are talking about alcohols that are primary and secondary. So when an alcohol gets heated under strong reflux setup, when it gets heated strongly under a reflux setup, it can change from an alcohol into a carboxylic acid. Now, a reflux setup is needed because it allows the alcohol to completely oxidize into a carboxylic acid, whereas the alcohol can partially oxidize into aldehyde, and then it's condensed by using a condenser, and it reoxidizes so that it can form a carboxylic acid. In this reaction, there's a color change from orange to green, and when it changes from orange to green, we know that carboxylic acid has been produced. So here again, I just have a summary. A reflux is needed as a condenser prevents the alcohol from partially oxidizing into an aldehyde by condensing it so that it can reoxidize into the final product as a carboxylic acid. So obviously, as our reactant, the alcohol is changing into carboxylic acid, the functional group of OH changes into COOH, which is a carboxylic acid functional group. So here I have an example of propan-1-ol reacting with oxygen being oxidized into propanoic acid plus H2O. So from this we know it has changed into a different compound. Now, next we have the oxidation, which is partial, and this uses a distillation setup. So in the partial oxidation, the alcohol gets heated gently for a short period of time with the same reactants, potassium dichromate, and acid catalyst, sulfuric acid. So this produces an aldehyde. So we need a distillation setup so the aldehyde can be distilled out from the mixture earlier on to prevent the alcohol from completely oxidizing into a carboxylic acid. So the distillation is what allows it to be separated from the mixture earlier on to prevent it from completely oxidizing into a carboxylic acid. Similarly, there's also a color change from orange to green. And here I have an example again. So here we have propan-1-ol, this time reacting with 1 mole of oxygen, whereas in reflux we had 2 moles of oxygen. So this shows that it's partially being oxidized. And this forms propanol plus H2O, and propanol is a aldehyde because aldehydes have a CHO functional group. Next, we also have the oxidation of a secondary alcohol. Now, secondary alcohol, again, quick recap, is the alcohol with the OH functional group attached to 2 carbons and 1 hydrogen. Now, these alcohols undergo oxidation with sulfuric acid and potassium dichromate to form a ketone. Now, it forms a ketone as the ketones are not able to completely oxidize, and therefore they form ketones. So here we have pentan-2-ol plus oxygen being oxidized into pentan-2 on a ketone plus H2O. Again, there is also a color change from orange to green. Lastly, we have the dehydration of alcohols. Now, in this, again, the alcohol is heated strongly under reflux with a concentrated acid, and in this case we do not need to use potassium dichromate. We are just using a concentrated acid, and we can either use sulfuric acid or phosphoric acid. So in this reaction, the alcohol is heated strongly under reflux with the acid, and when this happens, the OH functional group is removed and it's replaced with a double bond which adds a cross, forming a alkene. So this reaction forms alkenes from alcohols. So here we have propanol plus phosphoric acid forming propene and H2O. H2O is formed as the hydroxyl functional group is removed, forming H2O. And that's the end of the video. I hope it helped, and thank you very much.